Hi. So if you're watching this video, it probably means that you're in E211 and you're doing the stress strain lab. I'm recording this video in the summer before the first time this lab is run in E211. So I don't know if this is exactly the same assignment you're looking at, uh, but that's not really the point here. That's not at all the point. What I want to do is use this assignment to give you an introduction to some basic Excel workflows. Um, and so I am going to use what I understand to be the assignment for the stress strain design lab. And I'm basically showing you exactly how to do it. But my goal here is not to be exhaustive, not to be completely accurate even, because I'm just talking about how to use Excel. So, I will show you some formulas just because I'll be clicking through things. You're welcome to come back and, pause the video and look at them and try to figure out exactly how they work. Um, But again, that's not the point of this. I just want to show you, if you're new to Excel, some basic techniques. And the focus here really is on clarity of execution. So not just accurate analysis of data and use of calculations, et cetera, but to try to display the information clearly. And the point I always like to try to make, or I always make with this, is that the first person you're communicating with is yourself here. It's really good if you spend the extra time, get the habits in Excel to be very clear with your layout so that 2 weeks from now, when you come back and look at this, you know what you were doing. 3 years from now, if you're at a job and you've done some kind of modeler in Excel, the clearer you make it, the better you're going to be able to use it later. Also, all the data display is really there for you to help you understand your data. So if I'm looking at a table of data, I may not have any inkling of what, or I really maybe not be able to make conclusions at all by looking at the table of data, but then if I plot it in a way that's meaningful, I can immediately see or understand things about the properties of the material or whatever it is I'm studying. So that's really the first point of using Excel in this way. But then after that, really, you're trying to communicate with others, your boss, your investors, whatever it might be. And so it's great if you can display your data in a way that they can get a hold of you. You can send them your Excel file and they can just look at it and understand what's going on. Or you can, if you do things this way, you can also pull finished graphics out of Excel pretty easily. Anyway, so that's my pitch for that. Let's just start at the beginning here. If you see, I have two sheets down here, one called raw data and one analysis. The raw data sheet is the data that I got from the Pasco MTS machine that you guys are using for this experiment. I did exactly what the assignment says. Let's go back, I'm following these instructions, let's imagine. And so I exported the position and force columns. Um, and I exported it as a CSV file. I opened that CSV in Excel, and then I immediately saved it as an XLSX file, which is an Excel workbook. I'm going to say this to you right now, and if you don't do it, what's going to happen is you're going to go through and do all this work on your graphic here. You're going to save the file as a CSV and lose all that work. So maybe you just need to go through that once to learn this, or just listen to me. So one thing I always do, and I would suggest you do it, is keep your raw data as you collected it. Now, of course, you should have you should keep the CSV file also, and if you're really doing this for an actual something that was important or pivotal, that you had accurate information, and or you were doing research, you need to have your original data so that somebody can check it. Changing data is unethical and possibly illegal. But not altering it if you have the raw data, right? If you're changing it so that you can analyze it and you keep track of how you're doing that, that's fine. Anyway, so I have this raw data sheet. The first thing I did here is that I right-clicked on it and I protected it. So I just clicked right now. I'll just do it. It's unprotected. If I hit Protect Sheet, there's some you can pick some specific details. The defaults ought to be fine. Now what this means, so this is protected, I can't come in here and change any of these cells. So I think the reason for doing that's obvious. Then what I did is I right-clicked and I moved or copied, and I actually copied this first, the raw data, made a new sheet, and then renamed it analysis. And so that's this sheet. And you'll see what I did is I kept the raw data in my analysis sheet, and I just gave it a different color. So let's just start with that. Their Excel is laid out very clearly. And there's a section at the beginning that's all about formatting the cells. So I can change the color, and that's what I did here, is to change the color of the text to make it lighter. So now I can now refer to these cells in equations, not have to go to another sheet, um, and still have the raw data, um, just so that I know that if I make some mistake or I change something, I can go back and look at the raw data. Um, but I did also unprotect this sheet so that I can change things I need to change if I want to in this in my set of data here. The next thing I want to point out, which again, by the way, I'm an architect, and so I have more of a focus a lot of times than engineers do on layout, is what some people would say, or beauty. That's not it at all. It's communication, and so I try to be very clear in the communication of anything I'm doing. And if you get in the habit of doing what you see here, and this is very basic, it's very quick to do, and if it's a habit of doing taking these steps, then you'll automatically have the clarity I was talking about. So anyway, what I've done is just I've laid out my data and my information in clear columns. So let's just go through some of the techniques I used here. I would always suggest having a title to make. I don't think I've ever seen an engineer with a title in their Excel um, work, but kind of obvious why you would need it. So the way I did this is I just selected these. So if I come down, let me go somewhere else. If I select a bunch of cells, actually, I'm going to go to View, and I'm going to turn on grid lines. This is the way people typically you see Excel. Why have that on if it's something that's complete or that you're not using? Um, Point being, this looks more like a finished graphic or something that somebody um, would want to use, as a tool. So anyway, another thing I do is it's just like so basic, but it's funny to me. I never see anybody else doing it, any engineers doing it. Is why is data always crammed up against the wall? See, this is what typically you see, and often it'll be like this, where you can't even hold on. Oh, it's because it's protected. I can't do that. It'll be like this, where you can't even see the full name of the cell. Um, so. Don't do that. But what I'm saying is I added some extra space between my data and the edge of the Excel sheet. I did that simply by right clicking on a column, and I can insert columns or rows by right clicking and hitting insert. So that's the first thing I did. Um, then if you are so let's say I'm down here and I want to make a title here with all these cells, I can just select them, and there's various ways you can do it. Let me just do this way. If I come back up here to home, I can go to merge and center, and I can merge these cells. There's other ways of doing it, but anyway, so now if I type something in here, it's just one cell. So that's what I did over here to make this title. Another point is it's very easy to move stuff around in Excel, and the very cool thing about it is that if you have equations or name cells or whatever you have in a set of data, and if you move it now, if I say Control C and I move it down here to Control V, all of those equations have been moved, and any references to cells that you've named are retained, so you can move things around very easily in Excel, just to reorient or reconfigure your information. So let's see what else. How did I get these lines and things? Again, this is a lot of people are not going to do this right off the bat, but I think it's a mistake. I would kind of do it as you go. It's easy to change. If you go to borders here, there's a whole bunch of different border settings. So if I go to all borders, I can get the lines. I can change the line weights on those. There's actually two. There's a thick outside border that I can do as a preset. So now I have the thick outside borders and the cells outlined inside. So that's what I've done here to get these different units or these different sections. Um, You can also then, this is not, for example, a double row or column. You can just stretch out your columns as much as you want to. If you want to make columns the same width, for example, you can select whatever column you want to, come over here to Format, and as I say, I'm trying to do the column width. I can come and type in. I can see I've already done that here because both of these have the same exact column width. But if I wanted to make a bunch more the same, or pick one column width that I liked and then apply it to a bunch of others, I could do that this way. All right, so then what else is going on over here? I have a section called terms. This is really important to do, especially, I mean, in school for sure, but these are all terms that you will have known from the lecture or discussion in the lab. And so for someone doing this lab, maybe these term names should be obvious, but that doesn't mean you shouldn't name them. It's really important. It's a good way also just to sort of outline what you're going to do. What are all the things I need to deal with? You create a term section and label them. And then what we're doing here is now let's say, so I'm going to call that the axial load P. Anytime I want to use axial load now, I don't have to type axial load. I can use P, and I can actually name a cell P if I want to. And we'll get to that in a minute. So I've got all these names. Let me see. Okay, how did I get this delta? If I go up in here to, and by the way, like I said before, obviously I'm going very quickly. So if there's something that interests you, then you just pause and go back and listen, or pause and look at the screenshot, the still shot. I'm not going to try to go slow enough that you could follow along. Because this is, there's a lot I'm going to cover here pretty quickly. So how do I get a symbol like delta? If I come here to insert symbol, there's a bunch of essentially languages here that I can go through and choose, and I can find symbols. Once you've, I think this is Greek and Coptic, Latin supplements. Well, that's what we're in right now. Anyway, you can find pretty much any symbol you want. Lots of symbols in Excel. And once you've used them, they'll show up in these recently used symbols. It's kind of clunky because once you pick one once, you have to close out of here. Okay, so that's how I got the symbol. How did I get a lowercase? So, and that's, change in length is displacement. LO, I'm calling that the original length. Could be gauge length. There's whatever you guys are talking about in class. How did I get this subscript? Back here in font, open this up. I can choose strike through, superscript, or subscript. So I can actually get pretty detailed in my layout. Again, a lot of people will not do this. I think that's a mistake. I think it's really good to not, to lay this out like you would be in an article as opposed to how it would be, I like to do squared instead of carrot top 2. Anyway, and so then I'm also defining some equations I'm going to use here with, stress equals P over A. I'm saying stress using this Greek symbol, for strain. And by the way, you would think that these are all standard. They're not really in engineering. Well, there's just because there's a history, right? So that's why, even if you're really used to a certain symbol, you want to define it, what it means for somebody else. Maybe they're from a different country and they use something else there. Let's look at coloring. So that's just coming. I can either I can apply color. The bucket is for the that's for the cell, and obviously the text icon is for text. These colors are actually going to be applied in my graph, so I'm keeping these consistent so that you'll see that if we go back to the assignment. Oops, that's the wrong thing. There's a screenshot of a diagram. This is a good moment to mention this. So for example, this is an SVG file, which is a vector file, which means these lines, we can zoom in as far as we want to. However, if you see something like this, and it's really low resolution, and it's a vector file, you just have to open it. If you do that, you'll see that it's very, I can zoom in as far as I want to, and the line weights are maintained. Anyway, so if I go back to, but I was opening that for a reason. So where is it? It's not there. What did I do with it? I'll just open it again. Oh, it was an Edge. I never use Edge. Um, what I was trying to do here was to show that I've got a table that I'm going to extract from Excel that's next to the graph. And so that's why these colors being matched is important. Okay, so we're back in Excel. So I've talked about the colors. I've talked about um, the how to get these different symbols or super subscripts. Um, what else here? So that's I've got a term section. What we're doing in this assignment is comparing really well we're doing an experiment where we're plotting stress versus strain. But one of the things we always want to do if there's a so we bought this sample from a company. We also bought the equipment from the company to test the sample. And they have published what they say the specs should be. So if we get specs that are very different than that, either we need to call the company and ask them what's up, or we need to realize that there's something we're doing wrong with our experiment. So we want a published specs section. I'm going to actually well, I guess I won't. These, you should look these up. Actually, sometimes when I've done this before, by the way, I did this for a different class several years ago, so I don't even know if these are accurate. Sometimes I change values in videos like this so that I'm not just spoon feeding accurate information. Anyway, uh, these are published specs. The source might be something, a link on the internet, and so I can take any of these. I can take a cell, and I just opened it up to show you that there was a source. So that hyperlink there was created by if you right click, you can add a link to the content of any cell. All right, so we have published specs that we looked up. These are in SI units. So we're going to, if you look in the assignment, you see that you have to convert them to US units IP. Um, and so how was that done? Well, this is the first time if you're just new to Excel, this is the first equation you'll see. Um, I and actually let's look back. So the diameter of this of the working portion of our sample is here. Um, if I let me see, it's interesting. Yeah. Okay. I'll typically one way to name a cell is just you see this is the cell name here. Um, I might have named these later. I'm not sure. So anyway, I could type in a name for the cell right here, and that does work. And you're probably going to do that. That's the fastest way of doing it. Another way of doing it is right clicking and hitting define name. Let's look at that for a second. So this is the name. Right now it's saying D underscore MM because the protocol for Excel is to guess that you're trying to name it whatever cell you've clicked with the cell to the left of it. This would be a good moment to mention this. So Excel is to me, it's just a visual coding language, but it's attempting. It's been around for a long time. Anyway, it's attempting to be user friendly. So there's a lot of built-in protocol guesses that Excel implements. I'll show you a couple probably as we go through this. Anyway, so that's one of them. But I've actually already named this cell. So if I go to Formulas Name Manager, I can see here I've named it, and I can edit it if I want to. And see where is that? Yeah, there it is. Okay, so that's if I right clicked, this is what I would get when I was naming the cell. But why would I do it here? Well, you see here there's this scope variable, and right now it says workbook. What that means is that the capital letter D for anytime I use that in an equation, it's going to uh, point to this cell in this sheet. So if I had a workbook with 50 sheets in it, I could name D once and use it in 50 sheets, and it would always come back to this particular cell. That's great, but let's say you don't want to do that. You want to have D mean a different cell on each different sheet you're using, or on several different sheets. Then you'd want to make the scope here a specific sheet. And to do that, you have to do that when you're naming the cell. I can't edit that right now. That's kind of weird, but I could sort of see why that'd be true because you could probably really get some confused coding if you were able to edit that here. Anyway, that's one reason why you would right click and add the name. So that's what I've been doing. That's why it won't show up when I click on them, the cells that I've named. Anyway, so what did I do here? And yes, let's just I can just change this to D. Not quite. I might have done this twice. I don't know. Let's see if that does do it. Um, yeah, it didn't do it. I'm not sure what's named D in this file, so it doesn't really matter. Um, we're still looking at the first equation, and you can imagine that instead of so here's another thing is if I select actually you know what let me just go you guys can scroll through this. I'm just playing around here. What is my let's see it's analysis F25. Yeah, it's interesting. Somehow that was overridden. So I'm gonna try it again. If I change this. Oh, I see. Oh, no, no, no. Now I get it. Okay. What I did was, this totally makes sense. This is going to be the D we're going to use we are right now we are converting from SI to US units. Um, the D that I want to use in my equations is going to be this cell. So I didn't name the D in millimeters. I named this D. Anyway, so the first equation that we're going to do here then is I'm going to convert from meters to inches. And the way I'm doing that is so I'm saying equal. I typed in F20 or I selected that cell and that would show up as F20. Let me just do it over here. Equals, if I say equals this cell, you'll see that it shows up as F20. And then I'm going to say times, so asterisks. And I've got conversions down here, meters to inches. But actually, got to divide that by, so I've got to divide that by 1,000 because I'm in millimeters, and that's where we get this value, right? So this is this value here. Um, and if I select the formula bar up here, it will outline the cells that are in this equation, which is very handy. So I can see I've got F20, I've got my meters to inches down here. Um, one other thing, so when I did it over here, I've got a bunch of decimal points right here. I've only got 3. What did I do there? Why is that the case? Your professor or TA may disagree with this, but I feel pretty strongly about it. And it's something that engineering students sort of refuse to do often. Um, if you look at this experiment when you do it, we're talking about like our modulus of elasticity is like over 1,000,000 psi, right? So am I going to do that to 10 decimal places, to 2 decimal places? Probably not. It's pretty clear this is not that accurate. We're not going to, and if we claim that we have 1,625,321, 625,321.0003 for a Young's modulus, and somebody, let's say a client, looks at that, they're going to, if they know what we're doing, they're going to think, these people have no idea what they're doing because that's way too accurate. Same thing if you put $5.21721, makes no sense, right? So I would get in the habit of start thinking what's a sensible accuracy to be claiming, not just using whatever you can based on the calculations you're doing. So I adjusted this based on that calculus, and the way you do that in Excel is using this numbers um, section of your ribbon up here, and you can. I'm just going to play around with it. There's all sorts of ways to adjust the formatting of numbers. Just realize that's there. Okay, so that's how you do equations, and so we've got so for example. Now I am using the diameter here. And so if I look at, this is another point I want to make. If I look at this equation and I'm saying this is area in inches squared, and this is the diameter in inches, I can look at this and say, oh, well, that's the area of a circle. Because I've got D, I go that's diameter, I know that 3.14 is pi approximately, and then I'm squaring it divided by 4. Okay, so that's something you really want to try to do also as you get into Excel is, and this is why one reason you would name cells is you want your equations to look like equations. Because another way I could have done that is you can make a constant in Excel by, there's a formatting convention where you say, equals, so if this is column F26, I could say equals $F $26, and that would make that number a constant. Um, and I could put that into an equation. But then you'll see that as you get into obviously more complex equations, it gets very confusing to understand what it is that or where your problem is if you have an issue. But if you name things accurately, then it looks like the equation that you wrote down in your notebook or that you're looking up. So anyway, that's a better approach. So what we have here is then other equations where we're converting. So I have a conversion section down here that I'm using, and these are named, and you'll see here, like I clicked on meters to inches, and here it is up here in that name box. The name is defined. Um, okay, let's move. So I think it's clear then how we got the published specs and either converted or looked up from um, SI to US values. So that's what we're done with this conceptual section. Let's look at then the body of how we just, well, let's look at a few calculations and then, because I'll show you some shortcuts, and then we'll look at the graph and talk about, well, anyway, let's just see, I'll just move through this. I'm not sure exactly what I'm going to do. So we've got our terms, we've got our published specs in the units we need. So then I want to start doing some calculations for stress strain, because that's what we're doing. So the first thing though I need I'm going to need the change in length. Right now we have change in length, the displacement position in millimeters. So I'm going to take let's see what I did here. I said B5, so that's the first position, and I multiplied it times the meters to inches. Anyway, and I did an equation, right? And let me show you something. If I now, so I'm going to do this in a separate cell down here. If I say, okay, B5 times meters to inches equals, and I now grab that, or I select that cell, and you see this little square at the bottom right hand corner. If I pull that down, that again, this is one of those protocols I was talking about. Excel goes, oh, I bet you just want to repeat that equation for all for the subsequent cells in the column, right? So I can just apply that equation one time, or enter that equation one time, and then apply it to the entire data set. I can do that then across this whole set here, right? I can do all these equations, grab all of these and pull it down and get that same effect. So that's a really handy shortcut for applying equations once you know what you want to apply. So I did, I converted the length from the data into inches. I converted the force from newtons to force pounds. Then I applied the simple, oh, by the way, why is this C5 plus 100? It's because in the equation, we pre-stress the sample by 100 newtons. So um, that's why that number is there. Then I did this, our basic load, stress equals load divided by, I'm sorry, strain equals displacement divided by original length or working length or gauge length, and stress is load divided by cross-sectional area. We already have all these terms defined down here. And if there was an equation required, we did the calculation. So now I have the basic data I need to make a stress strain diagram. So let's go ahead and do that, or look at that. I've got one here. How did I create this? First off, I went to Insert, Charts. Let's talk about charts for a second. Lots of different charts in Excel. I would suggest starting with scatter plots. And by the way, here's another tidbit of information, if you've listened this long and you're paying attention, that there's two things I'll say that are general that will help you. One is I love Google and I use all Google products, but I do not use Google Sheets for anything like this. I'll use it for basic stuff, just basically tables and things. In my experience, Excel is still much more advanced in its capabilities. So I would use Excel as opposed to Google Sheets. And if you're in a group, or even if not, first of all, it needs to be Excel on your hard drive. You need to, and you can get that free at Stevens, but you don't want to use the web app. The web app is really more of a display tool, um, in my experience. And so you want to research how to collaborate. That's a term. That's the term they use. You can set up your Excel files so that you're collaborating with your teammates, and you can just like you do in Google Docs, you can or Google, anything in Google, you can edit the same file at the same time, and all of you together if you've collaborated on it. Okay, so I've chosen. I chose a scatter plot. Because, well, I'm not even going to get this. This is going to get too long. I'm just telling you. I'm choosing a scatter plot with curves, um, that connecting the points, and I'll probably show you why that's true. Um, Another really helpful tidbit for you. Remember, this is not something you're doing just for an assignment. If you got this data, let's say you had done this experiment and you brought it in, the first thing I would do is quickly plot the data. You could even plot it without doing the conversions. Because, for example, let's say you did not have, it's just a convention to have stress be positive. It could be negative, and it might be negative in the presets on the Pascal you're using. Who knows? So this might look funky. It might look backwards and upside down. It might just look upside down. So if you plot it quickly, then you can realize you need to adjust your data so that you can get the graphic you want or the display form that you want. And that's another reason why you want to have your raw data, because now let's say I had to, for example, one way of doing this is just multiplying. If this was upside down, I could multiply my data by -1, and there's a quick way of doing that, which is a paste special. But then I've altered my data, and that if I don't do that in a systematic way, that could be seen as unethical, or even, like I say, could be shifty. Um, all right. Anyway, so I'm wanting to show us how to plot something So I've created here an empty scatter plot. If I right click on it, and I'm going to select data, I'm going to add data. I'm just going to call this stress strain quickly. Uh, Another thing, there are shortcuts for doing this, but I would, especially when you're a beginner, just go through it systematically. And the shortcuts don't always work, and you don't always know that until something funky happens later, and then you have to go back and reverse engineer to figure out what's going on. Anyway, um, so if I want to just plot my stress versus strain, the strain is going to be in the X, so I can come up and just select all of my strain values. So I'll just scroll down to the end, hit enter, and I'll do the same thing for the stress, hit enter, say okay, go back and look at my chart. Yeah, okay, so it looks like it's pretty much the same thing. What's the different about it? Well, one thing is that I've got a bunch of points in here, right? With this much data, I probably don't want that, so why don't I just right click, change chart type, and I'll come and just choose the curves. Much better. Um, what though is, if I were in class, I'd ask you, where does this stress strain, um, where are we fracturing the sample? And if we go back and we look at just oops, sorry. If we go back and look at just the data points, it's much clearer. All we're looking at here is that here we're cranking away, and you've learned, or if not, I'm not going to explain it right now, something about what's going on here, why we're getting this particular shape. There's an ultimate tensile strength somewhere around here where it's the strongest it's going to get, or it's going to take the most stress as the material can. Anyway, and then it drops off quickly and it breaks here. And then we kept cranking and quickly got to zero force being applied. But if we have this chart type, it looks like there's actually data. So an important point here is don't plot fake data, right? So don't just go over here and just get a bunch of data and put it in a chart. Look at it, understand what you're plotting, communicate with yourself. So we would want to go back in and find whatever. Well, actually, let's just go look at our data. And we could automate this probably, or I'm sure we could, but we can see here that so we go to the ultimate tensile strength somewhere up around here, 75 something. Then it uh, clips off, and then at 67,000, it obviously breaks. That's where it breaks and goes to zero. So we want to come back in and edit our data to stop at cell 179. So if I do that, edit this, and just so here, this is some Excel coding here. Sorry, I'm in my office and my light's off, and so I can't really see my computer very well. Okay, so okay, and now I have only the data that I should plot in that chart. Um, okay, so what else do we have going on in here? Well, we have, I'm going to right click again, we have another data set, so I can add multiple data sets in this scatter plot. I'll talk about that in a minute. Let's talk about some other things before I get to that. Um, how did I, um, well, actually, no, let's not do that. I'm gonna go look at the actual data the data points we've chosen here. I'm not going to explain them. That's something that you should be doing in class. But we'll look at some equations here and then get back to how it's formatted in the chart. Um, so we went through and we looked at the specs. And then now we have a section called experimental values. So these are the values that we're getting from our experiment. So you will have learned that Young's modulus, or the modulus of elasticity, um, is the slope of stress over strain. So well, it's stress over strain in the for strain values that are between 0.05 and 0.25% strain. That's described here in this paragraph, and there's a question about why you think that might be true, so think about it. Um, but the point is that if we then identify where we're at, where 0.05 and 0.25% strain is, and take the slope of the stress and strain for those data points, we can calculate the Young's modulus. So here just looking through our data, here's 0.00041, and the next data point is 0.00073. We're talking about strain. So that's about 0.05% to 0.25%, right? And so I've just identified this stress strain section. This is the part. These are the data points we want to use to calculate our Young's modulus. Then I used a slope equation to get the slope of that data set. So I'll make another point here. Excel is basically, you never ever again when you're using Excel with data, do you want to use a calculator? Excel is a calculator and a lot more, but do your calculations in Excel, right? And that's just point blank. One advantage to that is that Excel has lots and lots of equations built in. You can also code your own with macros and things, but so I just, and you can kind of go, well, I bet there's a slope equation. If I come over here and I say, I've never used it, but I bet there's a slope equation. Actually, let me get out of here. And I say equals, and I start typing slope. Oh, there it is. So, and then if you click on it, it will tell you basically what's going on with that, or how that equation works. If that's not enough information for you, you can always just go to your browser. There's a really, I don't start with the videos or anything. Go to the support, Microsoft.com. They have really clean descriptions of all their functions. So That's where I would go for more information when you're getting into more complex equations. Um, anyway, but that's how I got the slope here. I left it in scientific notation, but I could change that, right? You see up here it says scientific notation. I could change it to whatever I want. Actually, I'm just going to do that. I'm going to change it to number. I'm going to add a comma, which means and I'm going to get rid of, I think I have to go this way. Let me just spread this out a little bit. I'm going to get rid of the decimal points. So there's that reformatting of that number. I'm going to go back though. Just hitting Control Z. Okay. Um, I think these others, so for example, if I wanted to get the 0.2% yield strength, I could actually come in here. I'm going to show you quickly how to plot this 0.2% line. I could just, for the purposes of this, see where that line is crossing my chart, come in here, select the chart. If you zoom in, by the way, you can get more articulated. I can come in here and pick a point. I can find out what the values of that point are by just hovering over it. And I could use that, a value. What I did here, though, was use a more complicated equation. So I'm just going to put it on the screen. You can play around with it. It's a round down, which is just basically saying we're not going to have a bunch of decimal points in this case. I'm using index match and a true false component. So there it is if you want to figure out how to do it or research it yourself, do it your own way. The point is I am delivering this number from data here that I've calculated. And so that's why there was a difference to use it in that equation. What I did up here is I calculated the stress, obviously. Then I did a y offset. You can think about why that would be the y offset. I'm using this 0.002, which is 0.2%, which is what we're doing. That's our offset. And so I use that to get the offset values down here, right? And then I use this, then I calculate the difference, and I use that in this equation. Again, so I don't know how complicated your professor or TA wants you to get this. You could just draw the line and approximate it, or you can calculate it exactly. But this is just showing you the power of Excel. Now I'm extracting a very specific number from this data. And again, I wouldn't be able to do that by looking at the data. I need to calculate it, right? For the UTS, I did a round down max. So I'm just taking the max of this of the strain. I'm trying to remember where I did plus 22.5. I'm not even going to try to remember that right now. Yeah, anyway. But the -3 here, what's that doing? This is getting me from a value. So this is K179. So let's look at K179. K179 is 67,823, and I'm sure it has decimal points. If I use my round down, I change it to 67,000, which I think is more honest and more believable, and so that's why I did that. I don't know what your professor wants you to do, but that's what I did. So etc. That's where I'm getting my experimental values, and then that's where I'm getting these values here, right? And I think what I did to place these values from my calculations is just approximate. So I think, for example, this 76,000, or maybe not, maybe I found the actual, something I found frustrating, and I don't, I think the student one time told me that they figured out a way of doing it, but I haven't figured out a way of saying, I want this point, show me where that is in the data. You basically just have to go and search around for the data point you're looking for. But okay, so these are formatted points that are based on this data over here for my experimental values. So let's talk about how I did that. And again, this is a level of detail that a lot of times engineering professors are not going to be concerned about. I think if you look around, if you're going to publish a paper, the clearer you make your information, the more people are going to like it, basically, and want to read it. So I would get in the habit of getting pretty accurate. But you could do a lot of this like in Google Slides or in some Adobe product, Illustrator or something like that. So just take it as far as you want to in Excel. But let me just show you just some basic things here. I'm in a chart, right? I can do a lot to edit this chart. So if I double click, first of all, if I click on the chart, I go to see this little plus sign over here. This is showing me a lot of options as to what I can display in the chart. So I have axes and axis title, chart title on. That's why there's a chart title here. These axes titles, I'm not going to turn them off because then I'd have to re-edit them. But then you can come into them and edit them or create them. It just says axis, y-axis, x-axis when you first start them, and so you make them, you edit them as needed. Always use units, obviously. You can edit the size of your chart by selecting the axes and let's say I wanted this to start at 20,000. I can edit the scale of the chart with techniques like that. But what I was talking about, okay, the idea is, I can come and I can change these little tick marks on the X and Y axis. I can change, if this is, I have this in percent. That's something I had to do by just defining that in the number category here. Again, I'm just double clicking on a feature and this dialog pops up so I can edit them. Anyway, there's lots and lots of things you can do. You should play around with it. Let me just show you some basic formatting things. One cool thing about Excel is that it does, the basic formatting that comes out of the box works pretty well. So when I add more data sets to this, it will automatically pick different colors. So it's very user friendly, I think. But so how did I format these points? So first thing I did, you select the point you want to format. I can right click, I can add either data labels or callouts. So let me add a data label. You see that if I pull it down, we're going to zoom in. I've now got a leader because I had a leader over here. But let me just show you that. So I can now click on that leader and I can edit it here. I can say no line. So I come back, there isn't a line. I can make it a solid line. I can change that line's characteristics however I want. I can change the fonts. I can change the color. Like if I click on this here, I can format the border. So like I can give it a solid line and add color to it. I can format the interior, whatever I want to do, right? I can also set the data point to have a specific, let me see, let me do it on this one. So here, the data point, hold on a second. Okay, I got called away. Anyway, so you can, if I select a point, I can also format that a data point. So for example, I can give it a marker. Marker. So I use one of the built-in ones. So I'm going to do a square. I can give that whatever color I want, etc. Right? Fill it. That's filled in with a different color. So to reselect it. Y marker. border fill. Yeah, I know I'm going through all this really fast, but you can pause it and you just get the idea, right? So that's a border. Oh, that is that exact point formatted. Now I can add leader lines to it and format those. So you can get this pretty exact, is my point. Let me get this get out of there. I'm going to delete this one. And you can either do that in Excel or somewhere else. Oops, I deleted those by accident. This is, where it's kind of clunky. Like what happened right there is I deleted a bunch of stuff I didn't want to delete because it was the same category as something else. So if I have these selected and I think I'm just deleting that one, I'm going to delete all these. So I have to double click on this. You'll get used to that as you work with it. A couple other things here, though. For example, this is just a drawn line. So I just decided that would be a good way of doing that. To do that, I can go to Insert Shapes. I'm going to pick a straight line. If I hold Shift and draw in a direction, it will keep it orthogonal or either vertical or horizontal, and put it that way. Now then I can double click on this and I can edit it, make it thicker, change its appearance, etc. And so you can draw. So for example, this shape here, this little triangle thing, is something I drew with. Let's see, where is that thing? Oh, just like a free form sketch. You can do that, and I can now change the color of that. I can make it transparent, which is what I did here to make so that I could see the text through this little orange box. Okay, so point is, lots of things you can do to make this, and that you need to do if you want to make your chart look like the one that I have, or that's in the assignment example. Okay, so the the last big thing we have to do then, I guess, is just show how we plotted this second data set. And this kind of shows this. Oh, by the way, this arrow is something I drew on. This box here I drew on top of the, and you'll see where this equation comes from in a second, but I'm saying the little orange box I drew on. Okay, so if I so what I want to do now is I want to draw a 0.2% offset yield strength line. So basically, we're gonna take these data points that define the slope of our Young's modulus, and then we're going to project a line up through that's project that as a straight line up through our data set, and where that straight line intersects the data set is the 0.2% offset yield stress. The y value of that point is the stress. So to do that, I'm going to select data, create a second. I'm going to add a second data set, and that data set is going to, you can see it here, it's it's the stress and strain values for the offset yield strength. So that's the origin of that line, okay? But that's not actually that's just a few points. Actually, I'm going to show you. If I Okay, let me do it this way. So that's actually just a few points down here at the bottom. And so what I did was I took those points and I projected a trend line, a linear trend line that went up through the data set. So to do that, and I think one thing to get from this, besides just being able to do this, is that you have to be, and this is such a big part of this. I don't even call this design. This is just layout. But you got to be willing to learn the tool and play around with it, and you can't just go, well, it should be easier. It's just it's what we have. So I applied. Let me. This is the trend line. So if I right click on it, I can format the trend line. I'm going to make it exponential instead of linear, so that I can move it out of the way. What I'm trying to do, let me just do that. I'm moving that thing out of the way. I'm actually going to delete it because I'll come back. If I now select, let me go in here. So like I'm saying, I want to see this data set. Let's see, where is it? because it's already plotted. Oh, right. So this is it. It isn't those two. It's the offset strain, which is these cells here, and the stress. Again, I'm going through this quickly. If that's confusing, that's something you should have covered in class. But you see how it's invisible? It's invisible because I made it invisible. So I selected it. I'm formatting the data series over here, you can see. And if I come over here and I say solid line, there's those data points, right? And so what I did was, so I'm going to go back and do it. I'm just going to Control Z back. That's the data set. Then I selected that data set and applied a linear trend line to it, and that became this dotted line. Now, that's not exactly true, so I'm going to select this trend line. There's another step. And remember again, so I'm going to right-click and format it. Um, in this case, since we know it's a line, it's the slope of, stress over strain, then there are preset calculations in Excel for different types of typical trend lines for data. So I chose linear. I could choose exponential or logarithmic, whatever I want to. Um, in this case, linear made sense, but I actually had to do some more adjustments. I had to forecast forward and backward, not backward in this case, but you might have to. So let me go to, remember that's at 0.004 and just go to 0. See that now that's just the line that we had. That's not what we wanted. So I had to play around to get a forecast that I wanted, to get the visual line, the projection of that trend line, to go through the 0.2% yield stress point, and get something that would work for my graphic. And then I formatted the color, etc. Let's see what else. Oh, this. Okay, now so if I format my trend line, why would why do I have this equation here? Well, this is the equation of that trend line, and I can display it or not. So I can turn it off or I can turn it on. And this the coefficient that's multiplied times x is the slope, and so that is the same thing as that is the Young's modulus, right? This number over here. Um, so that's an easy way for me to display that value on the chart, and also then if it changes, it will change automatically, right? So it's not if I just type it in there, then I'm not really using Excel in the most powerful way that I can. Let me see if there's anything else I want to say. I'm gonna go and delete this guy, this thing. What else have we got to finish off? There's some calculations here comparing um, our experimental to our published data, and that's, like I said earlier, that's a big part of this. It's always important to do that. So you want to think about, what's the right statistical way of comparing them. Let me see if there's anything else I had listed in that assignment that I wanted to go over. Raw data, symbols, slope, round. No. So I think that if you followed along in this video and you pause and you go back and take the time to really learn the skills that I quickly showed, um, you should be able to do all the Excel layout that's in that assignment as it's written right now, at least. Um, I hope this was helpful, and ask your TA or professor questions.